Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.5, Problem 9. This is Section 10.5, Problem number 9. It says you can solve problems related to inflation using the compound interest formula shown above. Now, on the board here, it's not really shown above, but printed in the homework, it's shown in the previous problem number 8. They remind you what the compound interest formula is. And it says, how long will it take for prices to double if the inflation rate is 3%? And it says for inflation questions, annual compounding is assumed, and that means that m is 1. So the question makes reference to the compound interest formula, which they claim is shown above. So just to remind you what it is, the compound interest is a equals p times in parentheses 1 plus r over m, close the parentheses, raised to the exponent of m times t. So it says you can use that formula to answer inflation questions. And it asks you if the inflation rate is 3%, which is fairly accurate. Most years it's somewhere around there, around 3%. How long will it take for prices to double? So let's use this formula to see how long it would take for anything to double if it's at 3% compounded annually, so m would be 1. So again, in terms of doubling, let's call the final amount 2 and the principal or initial amount 1. You can do anything you want as long as the final amount is double the initial amount. So you could have, $3.58 for the principal and $7.68 for the final amount. Why pick something complicated? $1 starting amount, $2 final amount is a good way to figure doubling. So 1 plus r, the rate as a decimal, so the rate is 3%. As a decimal, that's 0.03. Over m. M is 1 because it said for inflation questions, you want to assume annual compounding, and it just reminds you very specifically that means m is 1. And then the exponent on the parentheses, m times t, would be 1 times t, and t is the unknown. That's what we're looking for, the number of years. How many years will it take for prices to double? So let me clean up this formula a little bit. On the left, I will keep the 2 equals. So now, 1 times the parentheses, I don't really have to write the 1. I can let the 1 disappear. 1 times anything, it stays the same. And in the parentheses, 1 plus 0.03 divided by 1. Well, 0.03 divided by 1, of course, is just 0.03. And I'm going to add 1 to it. There's a plus 1 in front of it. So 1.03 plus 1 is 1.03. And now the exponent, 1 times t, I don't really need the 1 times either. I can just call it t. So I have the equation 2 equals 1.03 to the t power. Now to solve that, I need to use logs. And I like to do that trick where I use the exponential equation to a log equation using that Ben and Benny name. And when I have it written that way, typically the base and the exponent are on the left side of the equals and the number is on the right. So let me write 1.03 to the t power equals 2. It's the same thing, but this way now it fits that form that I like, Ben, B-E-N, for base exponent number. The base is the 1.03, the exponent is the t, and the number is a 2. So let me swap that around to Benny, B-N-E, for base number exponent, and I start that by writing the word log. Then I write the base as a subscript. The base is 1.03. Then I write the number is 2. Then I put equals, then I put the exponent is t. So now I have to solve log base 1.03 of 2 equals t. So I want to use that change of base form where the common log of the number goes in the top and the common log of the base goes in the denominator. Again, common log is just base 10, and I picked that because the calculator will do it. So I have to figure out the fraction, common log of 2 in the numerator, and then common log of 1.03 in the denominator, and that will be equal to t. So common log of 2 we've done already a few times on the calculator. It is 0.301029995. And I'm going to divide that by common log of 1.03. And the common log of 1.03 is 0.012837224. And that's equal to t. So I have to divide 0.301029995 divided by 0.012837224, and that's what t will be equal to. So when I do that division, I get 23.449772225, and that's what t equals. So it'll take almost 23.5 years for prices to double if the inflation rate stays at 3%. So something that costs you $100 today, that same thing 23.5 years from now, approximately 23.5 years, will cost you $200, cost you twice as much.